So, fun story for you. When I was making this video on naming branched alkanes, I had to make it 10 times because I kept finding mistakes in the videos. It has honestly been a long time since I've done organic chemistry, and so much as I enjoy relearning the process, to let you know it is a hard process and it is something that does take time to learn. So take solace in this video knowing that it took me 10 tries to get this right. So, how do we name branched alkanes? We talked about in a previous video how you name straight alkanes. You have the prefixes meth, eth, bu, pent, hex, hep, all that. That gives you the number of carbons. The challenge here with naming branched alkanes is twofold. First of all, we have to find the longest carbon. So we're going to start in this video drawing out the longest carbon first, just to make it easy. I'll have a later video where we actually work a more complicated problem. But in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do an even 10, decane. So the name of your branched hydrocarbon, that last word that needs to appear in there needs to be the longest carbon chain that's there. Now, let's start putting branches on. So a branch is designated with a YL ending. So, in this case, let's say we have a line here. This is a methyl group. It is not a methane group, but a methyl group, so that YL designates it as a branch of the chain. But we need to specify the position. So, easiest thing to do if we only have one branch is to go to the end of the chain closest to that branch. This is carbon 1, carbon 2. So this is 2 methyl decane. Let's say we put a second one on there. Put it here. We still want to minimize the number, but we've got 2, 3 dimethyl. Now, did you see what happened there? When we have multiple methyl groups beyond the one, we need to do a prefix to designate how many are there. So di, tri, tetra, penta, hexa, all those. Let's say we have an ethyl group. Well, what we're going to do if we have multiple groups with different names, let's move this over here a little bit. We still need to specify the position. So 1, 2, 3, 4, 5, and so forth. Now, we're going to list the branches in alphabetical order, not with a prefix, but simply by themselves. So ethyl's going to come first, your methyl, and then your decane. Now, we need to specify the positions, 3 for the ethyl, 2 for the methyl. So there's 3 ethyl, 2 methyl, decane. Let's say we have another methyl group. In this case, we would have 3 ethyl, 2, 3 dimethyl, decane. So you're going to need a group ending in YL to designate that as an alkane branch. You need to put the number of the position, and if you have more than one, you have to use a prefix. Now, the challenge with these, beyond identifying the largest carbon chain, which we'll show in a later video, is not as obvious as it looks sometimes, is let's say you have this. So we have an ethyl group and a methyl group. So we can do 1, 2, or we can do 1, 2. Which one do we pick? Because the nice thing about IUPAC is you can still name it wrong and still be able to recreate the structure. It's just not named correctly. So how do we specify which one will work? Well, let's write it out both ways. So we have the ethyl group, the methyl, decane. So we can either say that this is 2, 4, 5, 6, 7, 8, 9 methyl, or 9 ethyl, 2 methyl, decane. Which one do we go with? Well, what we're going to do is we're going to compare the two names, and we're going to look for the first difference in the terms of the numbers. So in this case, this is a 2 versus a 9. Whichever one minimizes the first number. So in this case, this first number comes first, one's a 2, one's a 9. We're going to pick the one that minimizes the first number. So this would be 2 ethyl, 9 methyl, decane. Now, let's say, for counter argument, we had a diethyl group. And again, we can do 2, 9 diethyl, or 2, 9 diethyl. In this case, it would be a 2 methyl or a 9 methyl. So if we start with this as the leading carbon, this ends up being, We start with this as being the leading carbon. We have a 2,9-diethyl, 9-methyl. Or if we start with this as the leading carbon, we have a 2,9-diethyl, 2-methyl. We still have the 2 and the 9 here being the same, so the next difference comes at this point. So we would use this because this is the lowest number on the methyl. So a little bit confusing, but you'll start seeing this, and typically we don't do really insanely branched things. But in this case, we want to do the 2,9-diethyl, 2-methyl, with this being the starting carbon, because if we look at it, it's going to change the number on the methyl position and it will reduce it. So, sorry for the kind of choppiness of this video, but when you name the branched alkanes, identify the parent chain, give a carbon position that's going to give a carbon position. You need to name each of the alkyl groups that are coming off of it with a YL ending, their appropriate prefix. The order of the names is in alphabetical, so ethyl before methyl. If we had a propyl, it would be beyond methyl. We're going to use a prefix to designate how many of those groups are present. We're going to use a numbering system that tells us which carbon is on, and we're going to number the carbons in such a way that it minimizes. If we were to write it out in different orders, it would minimize the order of the numbers as they appear in the formula. So this is for easy branches. Let's say we start doing branches that look like this. What do we do? So I'll talk about that in the next video if you have a alkyl group that is actually branched coming off the parent chain.